So we will wait for 1 or 2 more minutes and then we will start the discussion. Things are audible, right? So, so today we will be having a brief discussion. Firstly, good evening to all. So this is a course, as the course is going on the operation and planning of power distribution systems, uh, which is offered by Professor Sanjeev Ganguly from IIT Guwahati. So here today we will be first going through the overview of the week 5. Three lectures were there, and out of these three lectures, we'll first go through the brief overview of what's the basis of understanding the reliability of the power systems or distribution systems at large. So the need of reliability assessment in the distribution system needs to be. I think the microphone was moved. So as far as the distribution system reliability is concerned, the basis of understanding the reliability is to have a overview of how the equipments would perform if and when there are system outages, system effectiveness would be rendered in a proper manner. Okay. So, as we all know that the, let's discuss about the overview of understanding the reliability and hint of reliability. As we all know that since we are shifting towards the smart grid paradigm, we all know that in the smart grid architecture, there are the emphasis is mostly given to the distribution systems. Okay, and the distribution systems. Okay, let me just. So with the bidirectional power flow in place. So the consumers have also become the prosumer, or become the prosumer since they are also producing the electricity. So previously it was mostly unidirectional. Previously it was mostly unidirectional, and now when we are shifting towards the distribution side, so basically, today, as I've already started, so we'll first go through the basics of the what has been taught, the overview of the uh, week, week 5 lectures, just a basic 15 minutes, and then we'll start discussing the previous year assignments and last year assignments too. Okay. There are 20 odd questions, and then we'll try to solve within this 2 hour session. Okay. So here, as we all know, the entire system was previously unidirectional, but now since we have gone towards the bidirectional power flows, where the distribution side has become highly dynamic in nature, so there the reliability of the system should be maintained at large. Okay. So here, based on reliability, we have two uh, segments. Okay, two segments where first we can classify them as a part of outages. So outages must be minimized as well as interruptions. Okay, so interruptions. So here mostly there are various reliability indices uh, which will be discussed. So a better understanding would be done will be delivered when would be from your side also, that when the numericals would be taken up one by one. Okay. So, but before that, there are outages where the outages can be uh, of forced type, or it can be scheduled outages, and it can be in the form of you can say partial. I think I'm audible, right? Anyone please just write in the chat box or just
Uh, you're audible, sir. Actually, I couldn't see the screen. Are you presenting, sir, screen?
oh, yes, I'm presenting. Yes, I'm presenting.
Maybe due to network, I'm not able to see the screen. Voice is coming.
I'm resharing. Is it visible now?
No, sir. Maybe network on my side, I think.
I have shared the screen. Is it visible?
No, sir. Actually, I'll leave now and I'll rejoin. Then I'll check that. Maybe network error from my side.
Okay,
Sorry.
I just confirm, let me confirm. So is my screen visible? I have shared the screen, so can you please anyone confirm whether the screen is visible or not? I have shared the screen. Just write yes or no in the chat box if you. Is it visible? Is the screen visible? Just write in the chat box.
Visible.
Okay. So then might be a problem from one person was facing problem. So okay, so let's continue the discussion on the outages part, and then we can move on to the interruption. So the need of system reliability, why the distribution system reliability needs to be emphasized at large. Uh, this part needs to be focused as we are aiming or driving towards the bidirectional power flow where the customers which were mostly customers previously, now they have become the producers. So uh, uh, bidirectional power flow is enabling these customers to become prosumers, right? So, so here the outages needs to be scheduled, and some are forced outages. These are categorical classification of how the outages are faced in the distribution side. As we all know that when the that there are large number of topological changes. So is it visible, ma'am, for you? Because others for others the screen is visible.
I think it's error from my network side, sir. It's okay, sir.
Okay, okay. For others the screen is visible, so I've confirmed.
Okay. Okay, sir. Okay.
So there are the outages where the here mostly in the forced outages where there can be the equipments may go out of service, or there has to be in the scheduled outages there are equipments where we can see for the power plants, let's say, or the distribution system substations, there can be equipments which needs proper scheduled maintenance. So for that a systematic outage we can be at place. So for that we need to prepare our systems or to equip our rest of or the remaining part of the system so that uninterrupted power supply should be maintained. Okay, so this entire week's discussion was mainly given emphasis. The professor has given mostly emphasis to the how the outages and interruptions they will be in the distribution side, right? So we can't uh, change the momentary operations of the sudden system interruptions can occur, but we don't have the capability to. We try, definitely, we try to prevent all these things with various adaptive schemes. But for the time being, let's consider that these things would be in place, and considering all these things, there are the reliability indices where based on which system or overview or the picture can be framed that what things needs to be taken into granted and which things needs to be uh, taken into consideration so that the reliability is ensured all throughout for the system operation. So for the interruptions also there are momentary interruptions, and there can be the scheduled interruptions. So all these things you have gone through, right? Sustained interruption. So On the basis of these, the distribution system reliability is maintained, and there are the indices, as we have all seen, that the reliability indices like the PSI-T, PSI-D, KD, and all these things, as a large number of indices are being detailed in this week's lecture. So we'll go through the numericals, and based on that, clarity can be obtained. Okay. So the distribution system reliability in the current framework, the topological overview of the distribution system, there are a large number of topological changes, right? So they can be in the form of loads being uh, uh, suddenly changing the framework of the we can say that due to the large DER penetrations, the load side behavior might change and suddenly, and the intermittency, and based on that, the protection schemes might alternate their behavior, and based on which, since the system is also in a learning phase, right? So these are the problems that we observe in the current framework or current distribution system scenario. So some of the indices or the reliability studies can be in the form of so ultimately we have to minimize the cost, right? The cost of operation, cost of equipment failure, and everything. So everything boils down to the cost. So there are the studies based on which how the feeder length should be ensured, what will. So so everything comes to the system automation and system feeder level automation and control and all these things, so that the cost should be at its minimum point. And there was a cost curve being discussed. So where from the cost curve we have found out the optimal cost of operation, right? So you have already seen. So just giving a brief overview of from the optimal, how the optimal cost can be ensured. So the based on a point, here it is the optimal point, let's say, where the resultant curve, this is the cost of, because each and every time when we have an equipment in use, so for that equipment to be used in the distribution side for a longer period of time, there has to be some investment, right? So there has to be some investment. Let's say on the left hand side it's cost, and it's in this x-axis it is reliability. So uh, so when we frame the generalized cost curve based on the optimal point, so that the cost of investment and interruption cost, since the interruption when interruption cost. So this is the optimal cost. So this is the optimal cost at which the system reliability would be ensured. Okay. So a point of time may come where low cost would be, a point of time will definitely come where the cost of the equipment would become a very less. But for that to become cost to become very less, the investment, or we can say the maintenance cost to become very less, the capital investment should be ensured at a much higher scale, because the equipment would have to be, means initial cost of equipment would be very large. So there has to be an optimal choice. So that so here we can find that this is the bathtub curve, as I was discussed. So bathtub curve, based on the bathtub curve, this is the point where the optimal cost can be ensured, and the optimal reliability can also be ensured at a fixed cost. Okay, minimal point. Okay, so so anything that we need to discuss more, because we'll go to the numerical discussions, because there are around 20 numericals we'll discuss today, so it's better we start early. So mostly this was the overview. This was mostly a numerical week. All the problems were mostly numerical, as sir has also detailed some and some. These are the assignments from the last years, and we'll start discussing one by one. So if you all agree, so we can start solving the numericals. Okay, then. So this is the generalized statement, or we can say the question. This is the question. A distribution feeder is connected to 5,000 customers. Okay. The record shows that there are 6 fault events in a single year, and the total connected load is 15,000 kilowatt. The total number of customers who experience at least one interruption is 1,500. So the first question is, so just go through and let me. Question is, first one is, I think, sci-fi. Find find out sci-fi. So first one is find sci-fi. So what is sci-fi? As we all know that it's sci-fi stands for system average interruption frequency index. Okay. So, and what is the formula of sci-fi? So as we all know, it's the total number of customers interrupted divided by total number of customers interrupted divided by total number of customers served. So based on the question, so we need to find out psi. So total number of customers interrupted. First, we need to find out the total number of customers interrupted. So what will be the case here? Number of customers interrupted can be found out from the total number of feeder is connected to. Here the customer served is given as 5,000, right? So and the customer number of customers interrupted. So as we can observe here, so 500, then 700. So the total would be 0, 5, 5. So it is 2550. This is coming to 2550. So total number of customers who got interrupted is summation ni by total sum of the total customer number in total interrupted by total. So Interrupted is coming as 2550, and the total number of customers is 5000. So total number of customers 5000. So the answer would be, the final answer, 51. Okay. So any doubt? Any doubt? This calculation of psi. I think it's visible, right? Okay. Okay. Thank you. So this is for sci-fi, right? So let's move on to the next question. I think it will be sci. Yes, determine sci. Determine sci. So again, what is sci? So sci is given as, it was the previous one was sci. So it was only the number of customers, but number of customers, and there may be cases where customers, a single customer can have a multiple interruption. So the duration of the customers with the interruption time is to be taken into consideration. So here the number of summation of customer uh, customer duration with interruption. You can say like that. Customer duration with interruptions divided by, the denominator is the total number of customers. Okay, so here also the denominator is the total number of customers. Total number of customers. Yes, total number of customers served. So okay, so this is side sigma Ri Ni by Nt. Okay, so it is sigma Ri Ni divided by Nt in total. Okay. So what will be the answer here? So here's the duration being given. Okay. So what we need to do is just multiply the customers with the duration. Okay. And based on that, the numerator will be given. So please do start doing. I'll also do the same. So first one will be 500 into 2. Okay. So it's 500 into 2 plus 700 into 1.5 plus 1000 plus 50. I'm writing it directly. 1000 plus 50 because it's both of them are multiplied with 1. Then 100 into zero point 0.5 means 50 and 200 into zero point 0.5 means 100. So 50 and 100. Okay. So 50, 100. And the denominator will be same. Denominator will be 5000. So it's 1000 plus 1050. This one is 100, 1200. 2200. 3250 I think. 3250. So the final answer, so the final answer we can write it as 0.65. This was the answer given. Any problem? So this is the side. So any problem? Is it clear? Then we'll move on to the next question. Okay. Okay, then the next question is question number three. Question number three is question number three. Question number three is let me check. Question number three. Determine KC. KC. Okay. So this is the data given. So based on that, first here you can check what is KC. Total number of customer interruptions by total number of customers interrupted. So the customer is counted only once regardless of the number of times the customer got interrupted. So this is the formula of KC. So total number of customer interruptions by total number of customers interrupted. Okay. So total total number of customers is summation NI by CN. Okay. So total number of customers interrupted. So here we can total number of how many customers got interrupted. It was at least one interruption. So we need to take into consideration of this 1500 only. Okay. So the 1500 is the denominator. Sorry, 1500 is the denominator, and the number of customers who got interrupted, that is already we have calculated. So at least one, and these are the repeated times. So total number of customers who got interrupted. For each time, this may be a repetition. Okay, so 2550 is the repeated version of the number of customers. So at least one interruption, total number of customers is 1500. At least one. And in the numerator, it will be 2550. So the answer to this one is, I think, 1.7, because it is given. So any queries you have? So here the difference here is that in the numerator and denominator is that total number of customers interruption means there may be multiple interruptions to one consumer. Okay, so the a single consumer can have multiple interruptions. So for each interruption, it has been counted as one. Okay, but here, how many customers originally got affected? It is in the denominator. So 1500 were the number of customers. So some of them got multiple or repeated interruptions. So each and every interruption has been taken into consideration. So then overall, this is the answer of Kaifi. Okay. So next is the determine Kaifi. Kaifi. Okay. So again, this will be similar type of framework, but the customer interruption duration needs to be taken into consideration. But the denominator would be this is ID. So customer interruption duration is in the numerator, and so let me write, so customer interruption duration. But in the denominator, it will be the uh, total number of customers who got the interruption. So total number of customer interruptions will be total total number of customer interruptions. So the duration. So this is one formula, but again we have simultaneously we can easily calculate KID, but let's before that we can tally both the answers in both the way. So let us do it in the firstly in the basic way, and then we can use both the uh, formulas from the SciD and SciP, so that and we'll match the answers. Okay, so Here on the numerator we have the uh, RI NI, that means the duration for each customer, as we have already calculated. Okay, as we have already calculated, duration of each customer is 3250. Okay, 3250. So this one will be 3250, as we have already calculated it here. Okay, this one we have directly using this. So we are directly using it here. And this is NI. So what is NI? Number of customers who got interrupted, and this is the NI that we have calculated initially. Okay. So number of customers who got the interruptions, 2550. Okay. So this will be the final answer. Just 1.275. Just match the answers, right? And if you have any doubts, we can also discuss. But if you don't have, we can continue with the discussion. But this is the answer of chi-d, right? So the other way out to determine chi-d is that we have another parallel, easier formula when we have both the values of psi-phi and psi-d. So when we have the information of psi-phi and psi-d, so chi-d is psi-d by psi-phi. So what is psi-d? We have obtained 0.65, right? And psi-phi we have calculated 0.51. So just I think just calculate these. So it's again coming to 1.275. Okay. So both these answers match. So this is the similar formula. We can use numericals can come from both these types. So you might be given a data set from which you need to calculate ID, but if you are given parallel information of ID and psi with no information of the data set being given of the customer interruptions, so we can directly you can calculate the ID from ID and psi information. Okay. So any doubt? Okay. Okay, then we can move on to the next question. So, question 5 is determine ENS. This is question number 5. So, ENS is an important index which is also known as energy not supplied. Okay. So, ENS means energy not supplied. So, what is ENS? So, ENS can be given as a formulation of L average with Ri. So summation of L average, and what is L average? We can also form L average as a formula LP peak value into the load factor. Okay. So as we can see here, the ENS needs to be calculated, right? So how to calculate the ENS? Since we need to calculate the average, so from the data set, so since we are required to find out energy, so here is the power consumption, okay, and this is the R. So multiplication of the power consumption with the hour will give the uh, energy interruption, means the total energy that has been in total load interruption is 1000. So multiplied with the number of hours, the duration over which the load was interrupted. So we'll have a total of 2000 kilowatt hour. Okay. So similarly, if we calculate for all these, so this will be 7500. 7500, yes. Just write the unit here itself. So this one will be 6000, this one will be 500, this is 400, this is 250. Okay. So let's calculate the total here itself. It's 0, 5 here, 4, 5, 10, 14, 16, and so 6, 16. So this is the total energy loss or average energy loss since the energy consumption is given. So we can, so is first one was 2000, right? 2 into 1000. So summation of all the duration and the load loss. So or load interruption. So it's 1000 into 2 plus 5000 into 1.5 plus 6000 plus 5000 into 1.5 plus 6000 into 1 plus 500 into 1. I think. Yes, then 800 into zero point 0.5, then 500 into zero point 0.5. So this is coming to 16,650. This is the energy not supplied, or we can say similar to, we can say 16,050 units. Okay. So this is the ENS. This is the ENS. This is the answer. So read out. So so this is using the tabulated data that has been given. So using that, we have directly calculated. These are simple problems, but we need to keep these formula directly in mind so that we can solve them directly in the exam. So, so let's move on to the next question, which is question 6. Question 6 is determine ENS. So what is AENS? Already ENS we have written. This is average energy not supplied. Okay. So total energy not supplied already we have calculated, that is ENS. Total energy not supplied divided by the total number of customers. Okay. So here the total number of customers, uh, 5,000 customers. This is the in total. In total, NT is 5,000. Okay. So total number of customers served is 5,000, and we have already calculated the energy not supplied. So energy not supplied is 16,650 divided by 5,000. So 3.33. 3.33 is the answer. This is the AENS, average energy not supplied. Simple. So total energy not supplied. This is we can also imply as ENS, and this is the NT. So ENS by NT for individual customers, we can also represent them as the summation of the total number of energy that has been interrupted or total energy that has not been supplied to the customers. Okay. So as here it is L average for individual customers. So L average I into RI divided by NT. This is the formula of EPS. Okay. So any doubt? Otherwise we move on to the okay. So question number 7. So question number 7 is determine ACCI. So what is ACCI? ACCI is average curtailment index. So total amount of energy that has been curtailed. So on the numerator, total energy that has not been supplied divided by the total number of customers affected. So total number of customers who got affected. So we can uh, this numerator is similar to ENS, energy not supplied. Okay, so that means it is in average RI or ith individual ith customer multiplied with the duration, that is RI, and total number of customers who got affected. That means here the total number of customers who got affected, what will be the value? Whether it will be NT or CM, anything. Which one will be the denominator here? Out of NT and CM, which one will be in the denominator? So here in the denominator, it will not be NT here. Okay. The customers who got affected was NT. CM, yes. CM. So total energy we have already calculated 16,650, and CM we know which is CM, at least one interruption. So this one is CM. 1500 is the CM. So if we calculate this, the answer would come as 11.1. I think for 2 also 11.1 answer. Is it coming to 11.1? Let me use the calculator. It's coming to. Oh, okay, 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 okay. Yes, yes, yes. Sorry. Yes, yes. CN is 1500. Okay, then it will be divisible, I guess. So 15 here it is 10. It is 1, 1, 1. Okay, yes. 11.1. Yes. Okay. Sorry, sorry, sorry. I missed it. Okay, yes. So 11.1 is the answer. Here it will be CN. Okay, so shall we move on to the next question? Okay, question is, So now it's determined ASAI. So what is ASAI? Is average service availability, average service availability index. Okay, ASAI. So so the previous ones was related to the curtailment, and this one is related to the amount of service availability. Okay, so that means we need to take into account the uh, customers who have got their service for a year-round uh, output. Means the output will be taken for a year-round system for 1 year to calculate this ASAI, year-round data. Okay. So based on this, the numerator is customers service availability in hours, and in the denominator it will be customers. So there would be a certain gap between the customer's availability. Means there can't be gap too, but it's most likely that in the current context of the distribution systems or the indices that we are trying to calculate or understand the reliability of the performance of the distribution system is mostly taken into consideration where the customer service availability would be for the distribution system operator. They would definitely try to maintain the full on service availability, but conditioning to the customer's demand or service demand that the customers require, there can be we can say a falter by the uh, distribution system operators, or there can be lack or shortage of the availability based on the demand that has been provided. So total number of hours in a year the customer has been given the service would be in the numerator. So here mm, hours per year minus RI in I. Okay. And in the denominator it is NT again, number of hours per year. So based on this we can calculate NT. Okay. So here NT, as we all know, NT, we have the value of NT as 5000, 5000, yes. So NT is 5000, and number of hours in a year, it is 20, it is 8760. 8760, total number of years. it is 24 into 365. So 24 into 365, 8760. Okay. So considering 8760 here, and RINI, we have already known the RINI value. RINI is yes, 3250. RINI is 3250. Here, from here we can directly refer this black star. So this can be referred directly, and 3250. Already we have calculated previously. Okay. And in the denominator, again it will be 5,760. So numerator, the difference in the numerator would be very less. Let me just five minus 433. Yes. The answer is coming to 99.99. This is also given. So mostly there was no interruption, as we can all see that 99.99% of the time there was a service reliability. So so is it fine? This is the answer. This is the interruption. So this is the total. This means total on time minus off time by total. This is the simplified formula we can understand for our basic understanding. This is the simplified. It's not in a simple manner, but you can just remember this formula based on the simple mathematical equation. So of time, we should see here long time. Everything is time. Okay, so it is fine. Then we can move on to the next question, right? Determine ASI BI. This is similar to SID, but just the A is in now in the front and S is in the second place. Just average system interruption duration index, and previously it was system average uh, interruption duration index. Okay. So what is SED? Here it is average system interruption index. Okay. So the formula for SED, we can write them is we have the information of the kVA, how much kVA has been served here. Okay, so since we have the total load connected, now since we don't have the information of the power factor given, so for these cases we can consider the power factor to be 1. Okay, so no information of the power factor given, so we can continue using the kilowatt value as the kVA value, because uh, considering this or assuming that the power factor is 1. Okay, so that's if nothing is given, so definitely go for the power factor 1 value itself. So what is SED? It is the connected kVA interrupted duration and divided by total kVA served. Total kVA served. So connected kVA, since we have the information of RI, LI or L average AI, anything we can write, divided by total load, total kVA. So since we don't have the power factor, so considering the power factor to be 1, as the information is required here, so since it is not given, so total kVA interrupted duration, okay, so total load interrupted and the duration. So Ri into load. That means the value we have obtained in this energy column. So this amount of, so it will be 16,650 divided by total load KVA. It is total connected load. It is this one is LT, total connected load. So total it is given 15,000. Okay. So the final answer is again 1.11. This is the total connected load. Okay. And this one is the RILI that we have calculated previously. Okay. So, so any doubt? Otherwise, we'll move on to the next question. Yes, 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 yes. That one is the average consumption. Okay, so L average is the average loading scenario or the ith loading scenario. So we can consider both of them to be same. Okay, L average and Li. Li is the ith load, and yes, okay. So so okay. So let's switch on to the next question, right? Question. This is question number 10. So determine each ID. Okay. So this is also the index. So what is sheet ID? What is sheet ID? So it is also the customer interruptions, but total average sheet ID is the customer total average interruption duration index. Okay. So so we can say it as the summation of the duration of total. Since total is there, so summation of the duration of customer interruptions, and in the denominator we can say total number of customers who got interrupted. Okay, so from the formula we can write them as RINI, summation of RINI, and number of customers, total number of customers who got interrupted, who actually got interrupted, we can say who actually got interrupted. There can be cases of one customer getting multiple interruptions, but for the time being, we need to consider here in the denominator the number of customers who actually got interrupted. Okay, so we shouldn't calculate or shouldn't take into consideration those customers who got interruption multiple times. Okay, so this is CL. So that means this R can be written in small or caps, anything, because this is the RI in NI. So when we go back to the number of customers, we can see this is the number of customers who got interrupted multiplied by the duration of the interruption. So we have calculated that. Yes, this star one. So I am just giving the star mark here again and writing the same value. Okay, because this is the black star. So the value would come as 3, what was the value there? 3250. 3250. 3250 divided by CN. So total number of customers who actually got interrupted is CN. So 1500. We have already seen 2 3 times. CN value is 1500. So this will be. I'm writing the final value. Okay, so it is given as 2.17. So please match with the answers here. Once value is coming as 2.17. Okay, so okay, so any questions till now? Then there is another data set which is based on the assignments given in the, which is based on the another data set but the questions would be kind of similar again. So any doubts? So for the other set of 10 questions, we'll move faster since we have already gone through the questions and the formulas. So if there is a new formula that we'll discuss. Otherwise, if the same formulas would be used, so we'll try to do it first, and because we are around 30 to 35 minutes left, so we'll move a bit fast. Okay. So, any doubts, or shall we move on to the next set of questions? Okay. Okay, so let's begin the next set of questions. So here the question, the data set, please go through once. And so distribution feeder is connected to 6,000 customers. So total 6,000 customers are connected. The record shows that there are 5 fault events in a single year. The total connected load is 20,000 kilowatt, and total number of customers who experienced at least one interruption is 1,500. So these values are same, but the other values, so values would differ, but the procedures won't. Some options are also given here, so I'll just try to give the options too. So you have gone through the data set. So the previous one, the number of customers were I think 5,000. Here it is 6,000. The 15,000 kilowatt of total connected load, that is now 20,000 kilowatt, I think. Yes, 20,000. Yes, but the at least total number of customers who experience at least one interruption is 1,500. So minimum count of customers remains the same. So okay, so let's move on to the first question. So we'll switch on to the data set as and when required. Okay. So question one is to determine psi phi. So determine psi phi. The options are 2.5, 0.75, C is 1.5, and D is 0.40. Okay. So what is psi phi? Directly we can see it is Ni by N total. So Ni by N total. Okay. So please calculate based on the data set given, and please find the solution. You not just need to calculate psi phi. Okay. So so required I can D 0.40, right? Yes, 0.40 is the correct answer. So let's just do it fast. So it is psi phi is in number of customers interruption. So let's just sum all these first. is 0, so it's 0, 0 again, 1, 2. Is this value coming to 2400?
Yes.
Okay, so this one is 2400 and the number of customers is given as 6000. So yes, summation of NI by NT. So NI is 2400 and NT is 6000. So let's see, 0.4. Okay. So yes, that's it. So, right answer. Next one is to determine psi d. So, okay, we need to see the data sets. Calculate psi d for the same set of questions. So we have calculated psi d previously. So this is the formula where the duration needs to be taken into consideration. So I'm just opening the data set so that you can calculate. Once you are done, please respond. 5.6. 5.6 is not in the options itself. Psi d. So duration you need to take into consideration. So what is numerator by denominator? The denominator.
I have done wrong, sir. I have done wrong.
Mm, yes, 0.75. Okay. Yes, 0.75 is the correct one. Mark it here and do fast. So ID is just the duration needs to be taken. Customer divided by NT. So RINI divided by NT. So it's coming to RINI calculated 750 plus 1500 2050 plus 200. And in the denominator we already have 6000. 6000 customers. Yes, the value would come to 0.75. So moving on to the next question. Determine KFE. So for the same data set, determine KC. So let me keep the options to the options given. KC is 437, is 6, C is 1.53, and D is 0.51. So these are the options. Okay. So just take a note of these and take a note of this and you can just calculate the KFE. Is the answer that you have given B for this one for KFE? Okay, yes, yes, yes. 1.6 is the right answer. So yes, 1.6. So KFE can be given as the total number of customers interrupted divided by the total number of, I think this one will be interruptions and customers actually interrupted. So total number of customer interruptions is this one, NI. This one is NI. And this one is the total number of customers actually interrupted. So NI by CN is the summation NI by CN. So NI was 2400 and CN is 1500. Yes. So, okay, the final answer is 1.6, right? Yes. So, the next question is determine ID. So, we need, so determine ID. So these are the options. Just take a note of these and just open the data set. You need to calculate ID. Okay. Yes, 1.875 is the right answer. So one way is to directly calculate the ID. Directly we can calculate using this formula, right? ID is psi by psi. So we can, since we have both the values of psi and psi, so we can directly use these two values to calculate ID. Okay. So first let's do it using this one only. Then we'll go for the psi d. ID is psi d by psi. So psi d we have calculated 0.75, and psi we have calculated zero point 0.4. So from these two you will get 875 one way, and the other way is to calculate as per the formula. So customer interruption duration divided by total number of customer interruptions. So customer interruption duration we can calculate from the these two values, using these two values. Um, we have already calculated this numerator total customer duration summing up to 2000, 3000 customer duration. We haven't calculated, right? Total customer duration. Here the value is 500 into 1.5. So this value is coming up 750, 800, 800, 1000, 3000, 4500. So 4500 in the numerator, and total number of customer duration, customer interruption, customer interruption duration is coming to 4500. Yes, and total number of customer interruptions, customer interruptions, so total number of customer interruptions, uh, yes, total number of interruptions we need to C16 A9, total number of interruptions to 2400. This value A9 we need to take this value. So okay. So it will come to 1.875 only. This is Ni, summation of Ni. This one. And this is RINI. RINI. Okay, so moving on to the next question, determine ENS. So both these values would be similar. Anyhow, you need to calculate the this one and this one, both would be same. So moving on to next to calculate ENS. Okay, please calculate ENS. I'm writing the options. Five. Energy not supplied. So options are, I'll just move on to the data set. So that let me write the options. B is 40600, C is 36000, and D is 33600. So you need to determine ENS, energy not supplied. These are the options. Okay, just go through once. 42300, 40600, 36000, and 33600. Okay. So this is the data set again. So started calculating. So kilowatt hour can determine it from here itself. 0.005. Is this value coming to 33600? Okay, fine. So this is the ENS total kilowatt hour. So it will be L average into duration. So yeah, just we need to calculate ENS. ENS is equal to L average for the ith instance multiplied by the duration. So when we sum all these as we have done here, It's coming to 33600. So the answer is 33600. You can just put in a mark here so that if you go through this PDF again, so you can directly refer to the indicated sign here. So this is the 33600 is the duration that was calculated. So energy not supplied. This is the value. This is the answer. Next question is AENS. Determine AENS, average energy not supplied. The options are 21.15, B is 5.6, C is 6.04, and D is 13.82. So average energy not supplied is given as energy not supplied in the numerator divided by the average energy needs to be calculated for whom? For the customers, right? So the average energy not supplied would be in the numerator, it would be the total energy not supplied divided by total energy not supplied divided by the total customers served. So it will be 30 divided by 6,000. Total number of customers was given as 6,000. Total connected to 6,000 customers. 5.6. Yes, 5.6 is the correct answer. Yes. So it will, yes. So question 7. So here is the ACCI. Determine ACCI. What is ACCI? Average customer curtailment index. So this is the formula. L average into RM is the duration, total energy that has not been supplied, or the duration over which the total energy has not been supplied, divided by the total number of customers who actually got affected. So, so that's ACCI. Okay, just let me give the options. ACCI is 22.4, B is 5.6, D is, sorry, C, 13.82, and D. Okay. So ACCI already duration we have calculated, right? total energy not supplied, ACCI, total energy that has not been supplied. So the time of interruption multiplied with the total connected load at that instant. So this when multiplied with this would give the value of total energy, the total kilowatt into the hour. That will give the total amount of energy that has not been supplied over that duration, right? So here we have already calculated this value, summation of L average for the ith instant multiplied by duration. And in the denominator, it will be the total number of customers, those were not actually supplied. So CN will be 1500, I guess. Since the not supplied means CN and this is CN, 1500. Okay. So the answer will be final value directly writing 22.4. Is it same? Okay. So moving on to the next question is determine ASAI. This gives the service availability index. Okay, so the options of ASAI are so so we have already calculated ASAI like the previous problem. Here we need to multiply the total number of customers connected with the total number of hours available hours in a year. That is the number of hours will be 8760. Already we have seen here. So 5000 here the number of customers was 6000 here in this problem. So 6000 into 8760 minus this RINI. So RINI will be coming as 4500, I guess. This value would give RINI. So this value is most probably this is 4500. 4500. This entire value. So we can directly what sign to give? Let's give ampersand sign, double ampersand to directly refer to this value. So we can directly calculate the this will be 4500, but here it will be 6000, the total number of customers, and 8760 is the total number of hours in a year, and in the denominator also the total number of available hours for each customer. So the answer again would come to 99.99%. Okay. So ASAI would be again 99.9. Is it same? Yes. Okay. So next, calculate or determine anything. Question 9, I think. determine SED. Determines SED. So the options are 0.92, 1.68, 1.65, and 3.03. So what will be SED? Considering the power factor to be one. So we have previously also we have discussed the same type of problem. So SED will be KVA connected, once total the KVA that was connected and that got interrupted at last, means the uh, duration of the, you can say, duration of connected KVA interruption. So since we have the power factor, we have assumed the power factor to be 1. So in the numerator, we can directly use the power value itself. And in the denominator, we have the total KVA served. So again, total KVA served will be yes, total kilowatt given. So from here we can write it as 20,000 kVA for UPF. Okay. So 20,000 kVA and 33600. So 33600 by 20,000. So yes, 1.68 is coming. So is it matching your answer to? Okay. So we have one last question of seat ID. Question 10. Determine seat ID. So the options are 1.98, 0.8657, C is 0.51, and D is 3. So these are the options. So we need to calculate seat ID. So seat ID can be, what is seat ID? Seat ID RINI by CN, total number of customers who actually got interrupted, and in the numerator duration over which the customer interruptions took place. Interruptions, total duration over which the customer was a customer interruption. So you can directly, and this numerator would come here as 4500, as we have already calculated here. We are calculated here double ampersand sign actually indicated. So so find it out here, and this will be duration, so RINI over CS, total number of customers actually got interrupted. So here it will be and total number of customers who actually got interrupted is 1500. So the answer is 3. Right? Yes. 3 is the correct answer. So that's it. That's it from my side. So we have tried to solve these type of assignment questions have been given in this week too. So I've gone through the questions, but we can't discuss it today itself. So quite similar questions. I think the data is just different, but the question set is nearly same. Type of questions are nearly same. So I suggest you to solve the questions accordingly, and you can take the help from this PDF. I'll upload in the drive link, and you can refer directly, and you will get the solutions as the kind of questions as we have discussed. So if you have any doubts, we can move on with the discussion, and otherwise we can end today's session and we'll join on next Tuesday.
Thank you, sir.
Okay. So if you don't have any questions, so we can end today's